Today we will start with chapter 4. It's all about functions, and we will consider some special functions called the linear functions, quadratic functions, and some other more. Okay, and for that, we will need to introduce a mathematical system. And this is what we're going to do. We will have the rectangular coordinate system. Okay, or sometimes it is called the Cartesian coordinate system. Okay, so what is this Cartesian coordinate system, and how do we construct this? So this coordinate system was introduced by René Descartes, a philosopher, French mathematician and philosopher, and that's why it's called Cartesian. So from Descartes, and this was introduced in order to at least visualize what is happening in some mathematical functions. Okay, so what is this Cartesian coordinate system? So let us consider two real number lines lying on the same plane, one horizontal and one vertical. Okay, the horizontal line, this line here, we will call it the x-axis. And then the vertical line, so this line here, we will call it the y-axis. And of course, we have horizontal and vertical. They will definitely intersect. So we will call the point of intersection the origin. Okay? And this origin later we will denote it by 0 or O. Okay? But of course, later we will see how we will denote this in terms of these two coordinate axes that we introduced. Okay? Now, to each point on the plane containing both the horizontal and vertical lines described, okay, we assign a coordinate. We assign a coordinate in which we denote them by an ordered pair x comma y. So for example, if we look at this point, it's just denoted as x comma y. If we look at this point, it's just denoted as x comma y. This point also as x comma y. But later, we will give them their specific names. And the specific names, they are based on their exact location on this flat plane. Okay? So, the coordinate system described is called the rectangular or coordinate or Cartesian coordinate system, or we simply call it the Cartesian plane. So it's a flat surface, okay? It's a flat surface where we think of a certain point to be our origin, and then we draw horizontal and vertical lines, okay, passing through that origin. Or maybe we can start like what was described earlier. We start with a horizontal line and a vertical line, and then the point of intersection, we will call it the origin. Okay? Now, you see that there are some ticks here, these small vertical lines in here, and also these small horizontal lines in here. Okay? They will determine the location of a particular object, say a point, on the Cartesian plane. Okay? So, the point origin, okay, the origin has coordinates 0, 0. Okay, meaning the x, you see how we labeled our points here. We have x comma y. Okay, so this means that the x coordinate, so we call it the coordinate, the x coordinate is 0, and then the y coordinate is also 0. So this guy here, the origin here, is also labeled as 0, comma 0. So it is the 0, comma 0 gives the location of that origin relative to your x-axis and y-axis. Okay? Now, if we look at the x-axis only, okay, we look at the x-axis only, all the points on the right of your O, okay, all the points on the right of your O, okay, will be labeled as x comma 0, okay, where x is a positive number. So for example, this point here, okay, we can label this as say x sub 1 comma 0, and maybe this guy here, let us label this as x sub 2 comma 0, okay. This x sub 1 and x sub 2 and all other points on the right of your 0 will have the x coordinate positive, okay. And those points which are to the left of the origin, okay, has coordinates of the form x comma 0, where x is less than 0. So for example, if we considered this point here, we have x sub 3 comma 0, and maybe this guy here, we have x sub 4 comma 0, okay. This x sub 3 and x sub 4, they are all negative, okay. So if we look at this, we have x sub 1 comma 0, x1 is positive, okay, while in here you have your x sub 2 comma 0, x2 is negative. So that's how we're going to name these points if they are on the x-axis, okay, and they are relative, or their location are relative to the point O. To the right of O, the x is positive. To the left of O, the x is negative. Okay? And then we will do the same thing for those on the y-axis. So now we consider this y-axis, okay? And then points on the y-axis which are above O, okay? So all the points somewhere here or here or here, these are all above O. They will have coordinates of the form 0, comma y, where y is positive, okay? So for example, if we label this as 0, comma y1, and then here you have 0, comma y2, these y1 and y2 are both positive, okay? And those points below the origin or below that O, say this point here, or this point here, if we label this as 0, comma y sub 3, and here you have 0, comma y sub 4, then y3 and y4 are both negative. So all the points below the origin and are on the y-axis has coordinates of the form 0, comma y, where y is less than 0. Okay? So for instance here, 0, comma y1, y1 is positive. Here 0, comma y2, y2 is negative. Okay? And now we have the following. The points, okay, with coordinates x comma y, okay? So the points with coordinates x comma y is the point of intersection of the vertical line containing x comma 0, okay? So x comma 0, for instance, this is your x comma 0 in here. You draw a vertical line, okay? You draw a vertical line passing through that x comma 0, okay? And the horizontal line containing the point 0, comma y. So if this is your 0, comma y, we draw the horizontal line passing through that 0, comma y, okay? The point of intersection here will be labeled as x comma y. So here you have x comma 0. Here you have 0 comma y. And this point of intersection will be labeled as x comma y. Okay? Okay. Now, this can also be thought of as the point whose signed distance from the x-axis is y, okay? And whose signed distance from the y-axis is x, okay? So, how is that? You have your y-axis in here, okay? You have your y-axis in here, and this is your point, okay? This distance, this here, signed distance, this distance here is equivalent to x, okay? So the distance from the y-axis is x. The point from the y-axis, it's x. And then the distance from the x-axis, so the point from the x-axis, this is your x-axis, it's equal to y, okay? And take note, we said here, signed distance, just for emphasis, meaning we consider positive or negative. We know that distance should be positive, okay? By signed distance, we mean if you have negative signed distance, okay, it must be to the left of O if it were in the x-axis, or on the x-axis, or below O if it were on the y-axis. Okay, that's your signed distance. Okay, so meaning if I still have some point here, which we label x comma y, okay, the value of x here, it's negative because it's on the left of O. The value of y here, it's also negative because it's below O. So meaning, we will still think of this distance as our x. So it's a signed distance. This is a negative number here. And this distance here, this is your y. So again, it's a negative number because we consider the signed distance. Okay? If we remove the word signed here, okay? If we remove the word signed here, we have to take the absolute value for the x here and then absolute value of y here. That's the actual distance of the point from the y-axis and on the point from the x-axis. Okay? So question so far. So again, in here, let me emphasize this. This is the signed distance. Signed distance. Here we also have here the signed distance. Okay? But the actual distance of the point to the x-axis, it should be absolute value of y. And then from this point going to this, it should be the absolute value of x. Okay? So actual distance. So in here, if we are going to talk about actual distance, so we remove the word signed, it should be considered absolute value of y. Okay? And then, of course, this distance here, okay? This is absolute value of x, distance. Because, again, distance, it should be positive or 0. Okay? Any question?
Would you be able to do one example with us about this?
Of course, we will have a lot of examples later.
Okay, thank you.
Okay. Other questions? Now, if P has coordinates x comma y, okay, then x here, it's called the x coordinate, or it's also known as the abscissa of P. But a lot of times we just use x coordinate. And then y, y is called the y coordinate. So this value here, the actual value here, we call it the y coordinate. Or it's called the ordinate of P. Okay? Ordinate of P. And then we write P equals x comma y. Okay? And the phrase, the point P, or the point x comma y, it means the point whose coordinates are x comma y. So this long phrase here, we will shorten that to this phrase. The point xy or xy, it is the point whose coordinates are x comma y. Okay? Now, if we go back to the Cartesian plane, okay, you have this x-axis, you have this y-axis, and then you have the signs on the x-axis. So to the right of x, to the right of O along the x-axis, those are your positive x values. And then to the left of O, those are negative x values. Okay? And then from O along the y-axis, those above O, we have positive y values. And those below O, we have those negative y values. And as you can see, the plane is divided into two parts. We call them quadrants. Quad to mean four. Okay? So, we will label this. Okay? We will denote this as our quadrant 1. Quadrant 1, or the first quadrant. This means that on the first quadrant, you have positive x-axis and positive y-axis. That's why it's in here. Because as you can see, if I get a point in here, the x value here, okay, this is your x value and this is your y value, okay? The x value, since it's on the right of O, it's a positive number. The y value, since it's above O, it's also positive y, positive value, okay? So plus, plus. And then from quadrant 1, we move counterclockwise. We move counterclockwise. So our quadrant 2 will be this guy, okay? And notice, in here, the point here has negative x value and positive y value. And then this guy here, it's quadrant 3. So again, we are moving counterclockwise. Okay, we are moving counterclockwise in here. Quadrant 3 has both negative values for x and y. Because if you get a point in here, it's on the left of O for the x, and it's below O for the y. That's why we have negative and negative. And then this guy here, we are in quadrant 4. The x value is positive, and the y value is negative. Okay? So quadrant 1, positive, positive. Quadrant 2, negative, positive. Quadrant 3, negative, negative. Quadrant 4, positive, negative. Okay? And these names, quadrants 1, 2, 3, and 4, they are known names. Okay? They are universal names. You go to a different school, different colleges, universities, etc. This is still the name for all of these quadrants. Okay? Now let's look at some examples. We want to plot the following points on this Cartesian plane. So here you have 1, comma 2 for number 1. So as you can see in this, I already labeled which are 1s and 2s, or -1, -2. So this guy here, it's 1 unit, okay, from the origin along the x-axis, okay? And then here, this guy here, it's 3 units from the origin, but to the left, okay? So along the x-axis, to the left of the origin. That's why you have negative value in here. And similarly, for the y-axis, this guy here, it's 1 unit along the y-axis above the origin O. And this guy here, it's -2. It's labeled -2. It's 2 units, okay, 2 units along the y-axis below O. Okay? So we have here 1, comma 2. So we want 1 unit on the x-axis and then 2 units on the y-axis. So this is your 1 unit in here. This is the 1 unit here for the x-axis. Okay? And then this is the 2 units for the y-axis. So if we use the illustration earlier, or the construction earlier, we draw a vertical line passing through, okay? We draw a vertical line passing through the point 1, comma 0, okay? So this is that vertical line. And then we draw horizontal line passing through the point 0, comma 2. And if we get the intersection, so this is the horizontal line. If we get the intersection, which is this point here, okay, that will be the point 1, comma 2. Okay? So let's see. That's your 1, comma 2. So you draw this horizontal, vertical line passing through this 1, comma 0. And then in here, horizontal line passing through 0, comma 2. The point of intersection is here. You have 1, comma 2. Okay? Another one here, you have -2, comma 1. So we look at -2, comma 0. So this is that point here. Okay? And then, just like before, we draw vertical line passing through that point, -2, comma 0. And then we need a y equals 1 here. So this is your y equals 1. We draw a horizontal line passing through that point. So we label it 0, comma 1. And the point of intersection, which is this, okay? This is your point -2, comma 1. Okay? So we
So
will see
uh,
that,
the
yeah,
uh, the zero the zero before you erased it. It's okay. So we had zero. We had, yeah, -2, 0. So -2 it's the y. No, it's the x, and then 0 is
yes,
the
it's
y,
the
right?
0, it's your y, okay? But when we write 0, it means you're on the axis itself,
Okay. Oh,
okay?
I see.
So
Okay.
you are on the x-axis here, okay? Your y is equal to 0, so you're on the x-axis. Here, your x equals 0, so you're on the y-axis.
Okay. Thank you.
You're welcome. Okay? So here's your point, -2, comma 1. Same is true with 3 comma negative 3. Let us reveal that 3 comma negative 3. So it's in here. So you have 3 units for the x and then negative 3 units for the y. So this is your negative 3 here. This is for the y. This is your positive 3 here for the x. Okay? So this will be the point 3 comma negative 3. So again, if we use the same method as in before, okay, here we will have this point here. It's 3 comma 0. And then this point here, it's 0 comma negative 3. So we draw the horizontal line passing through that point. Sorry, it should be horizontal. So you have this guy here. And then we draw vertical line passing through this point. And then you will get that point of intersection, 3 comma negative 3. Okay? So if you draw this grid, it can easily be seen, or the points can easily be seen. Okay? Because it's already in there. For 0 comma 1, so you have 0 on the x-axis and then 1 on the y-axis. So it's this point here. Okay? So we have that 0 comma 1 there. And then negative 4 comma negative 1. So you have negative 4 on the x. It's somewhere here. Okay? And then negative 1 on the y. It's somewhere here. So you have this horizontal line and then this vertical line. The point of intersection is on this part. Okay? So we see that's the point there, negative 4 comma negative 1. And then here you have negative 3 comma 0. So this is your negative 3 on x, and the y is 0, so you're on the x-axis. So you will have this particular point. Okay? So question. So in here, the orientation of your Cartesian plane, it's fixed. Okay? To the right, this is positive. Okay? These are your positive x-axis or positive values of x. To the left, this is your negative x's. And then above, this should be your plus y, positive y's. And then below, these are your negative y's. And then get a point. Say this particular point here. Let's look at this. Okay. So if you look at this, it seems it lies on this vertical line. Okay. And on the x-axis, you will have that negative 3 comma 0. Okay. So you write that negative 3. And then it seems that we can have this horizontal line. Okay. Horizontal line in here. And on the y-axis, you have 0 comma negative 2. Okay. Negative 2 for the y value. And therefore, this is the point negative 3 comma negative 2. Okay. And you might think, the coordinates, the values of x and y, they are integers. You can have some fractions. Okay. For example, if you look at this point, okay. So it's assume that it's at the middle of 1 and 2, which means the x-axis here, it's 1.5. Or you have 3 halves. And then since you're on the x-axis, the y-coordinate is 0. Okay? Yes, question? I think you have to unmute yourself. Oh, so your question is about step functions. Let's not go forward. Let's not go as fast as that question. We will see when we discuss functions. Okay? Other questions related to the current topic?
No, it's really clear. Thank you.
Thank you for the response. Okay, so we can identify points on the plane. Okay, we can now identify points on the plane. We can now give names to them. And if we have a name, we mean we have an ordered pair. Okay, so our next topic is what if we are given 2 points? Okay, what if we are given 2 points? Say this negative 2 comma 1 and then this 1 comma 2. Okay, how far is this point negative 2 comma 1 to the point 1 comma 2? Okay, so we will be asked to find the distance between these 2 points here. Okay, we will be asked to find the distance between those 2 points there. Or maybe if we have, say, this point negative 3 comma 2 and the point 3 halves comma 0, we may be asked to find the distance between those 2 points. Okay, etc. So the question is, how do we get the distance between the two uh, points? Or given 2 points, how are the distance calculated? Okay, so here we have what we call the distance formula. Okay, the distance between the points P1 with coordinates x1 comma y1 and P2 with coordinates x2 comma y2, which we denote by this d parenthesis P1 comma P2, okay, is given by this formula in here. Okay, so if you have, let's see, if you have this point P1, okay, P1, and then you have this point P2. So take note, I'm not even drawing the x and y axis here. So these are really arbitrary points on the plane. Okay, um, we can get the distance between these 2 points, okay, by using this formula. Okay, so we label that d. So the question is, how is this formula derived? Okay, how is this formula derived? You remember when we discussed formula, particularly when we have right triangles, and then we introduce what we call the Pythagorean identity or the Pythagorean theorem. So with that hint, what we're going to do is actually to draw a right triangle. Okay? To draw a right triangle. Okay? So this point here, we know is some point on the Cartesian plane. Okay? And this guy here, from this point, so assuming that this is your right triangle, okay? If you calculate this distance here, this is equal to the absolute value of x1 minus x2. Okay? So I will not show it here. Okay? But this distance here, it's the absolute value of x1 comma x2. Okay? Meaning, you look at the x coordinates of P1 and P2. Okay? So you get the distance of the x coordinates. So x1 minus x2, you get the absolute value. And then this distance here, this is the absolute value of y1 minus y2. So this time, you look at the y coordinates of P1 and P2, and the distance of the y coordinates, it's just absolute value of y1 minus y2. And then remember your Pythagorean theorem. Okay? If we label this as your C, this is your A, this is your B, then you have A squared plus B squared equals C squared. Or your C, this is square root of A squared plus B squared. But with this, your A, it's equal to absolute value of x1 minus x2. So if you square it, it's always positive. You'll get this part. Your B, it's absolute value of y1 minus y2. If you square it, you'll get this part. It's always positive, so you can remove the absolute value. And your C, it's just your D. That is the distance. So you will obtain this formula. So it's all about triangles. This distance formula is also about triangles. Let us consider this actual example. So you want to find the distance between negative 2, 1 and 1, 2. Okay? If we use the same illustration as in before, okay? You draw a triangle, okay? Particularly a right triangle. And this point here, you will see that it has coordinates 1, 1. So the 1 came from this 1 here. The x coordinate here came from the 1 here. And then the y coordinate 1 here came from the y coordinate here. And why is that? Because you draw a horizontal line passing through this point, which means the y coordinate is fixed. The one changing when you draw a horizontal line, for example, in here, when you draw a horizontal line, you get your point here, 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 okay? Assuming that this is horizontal line, your y value remains the same, correct? Only the x values change. If you draw a vertical line, however, so say this is a vertical line, you get this point, you get this point, you get this point, etc. The x value remains the same, and only the y values change. Correct? So, if I draw this vertical line passing through the point 1, 2, the 1 remains as is. This one here. The vertical line, the x value remains the same. While we draw horizontal line here, the y value remains the same. That's why you have your y value equal to 1, your x value also here equals 1. So that's the first. If we go back to this, let's see. Point P2, you have your x2, y2. Point P1, you have the x1, y1. Horizontal line here, the y value is fixed. So you have the y1. Again, horizontal there. So the y value is fixed. The y value is y1. Vertical line here, the x value is fixed. This is your x value. So this is your x2. So this point here, it's your x2, comma, y1. Okay? Now, let's go to this actual example. We now consider the distances. We now consider the distances. Look at this. On the x part, okay, meaning horizontal line here, we said that from this point here up to this point here, we'll have sign distance -2. Okay? The actual distance, it's a positive number. So it's just 2. Okay? And then from this point up to this point, the sign distance, it's 1. Okay? And of course, the absolute value of 1 is still 1. So what is the total distance from this point to this point? It's 2 plus 1. Okay? So that guy, this total distance in here, this is equal to 3. Correct? And what about this? From this point, let's see, from this point up to this guy here, okay, from this point up to your x-axis, the sign distance is 2. And of course, the absolute value is also 2. From this point up to this point, from this point up to this point, so this guy here up to this guy, the sign value is equal to 1. Your y here, it's 1. Again, from this point up to this point, your y here, it's 2. Okay? But now, you are only considering this part here. So from a total of 2, you remove this part here, you'll just get 1. So the height of this right triangle, it's 1. The base of this right triangle, it's 3. Correct? So the height, it's 1. The base is 3. Now, how do we get this 1 and 3 using our formula? The distance formula on a line is absolute value, okay? The distance formula on the line on a straight line, okay? So distance between x1, comma x2, this is simply absolute value of x1 minus x2. Whichever is smaller or greater, it doesn't matter. Okay? You have your horizontal line. This is your x1. This is your x2. And we don't know where 0 is. It could be here, it could be here, or it could be here. Doesn't matter. If you look at the distance, this is simply absolute value of x1 minus x2. And if you do that, the same formula in here, you will get that 3. Okay? You will get that 3. Absolute value of -2 minus 1. That's absolute value of -3, and that's equal to 3. Okay? Or here, up to here, absolute value of 2 minus 1, that's absolute value of 1. And therefore, you got here 1. Okay? Hence, we don't even have to write this third point here. What I'm saying is, you can only have, or you'll just need, the two given points. You'll just need this. You know your x, you know your x here, to get the distance relative to x, okay, or with respect to your x coordinate, absolute value, okay, let's write that, absolute value of -2 minus 1, and this is absolute value of -3, which is 3. And then you have your y, which is 2 and 1 here. The other guy, you will have absolute value of 2 minus 1. This is equal to absolute value of 1, which is just 1. Okay? And I say, it doesn't matter which you use first. In here, I used -2 and then 1. I got the distance to be 3. If I used 1 first, you have absolute value of 1 minus -2. This is what? Absolute value of 1 plus 2. And this is equal to absolute value of 3. And again, this is just 3. Similarly here, I started with 2 before that 1 there. I could have started with 1. So absolute value of 1 minus 2. This is absolute value of -1. And this is equal to 3.
So even though -3 became 3, it's because they both how to say that, they both like -2 and 1 and then 1 and 2 are in the positive side of the graphic.
No, it doesn't. No, it's not that. It's because you are considering the absolute value.
An absolute value has to be positive always.
Yes.
Okay,
Yes.
okay.
Okay.
So we always consider the absolute value always.
Yes, for the
Okay,
distance, because
for the distance. Okay.
we will our distance is always positive. Okay, it's
Okay.
not designed distance.
Okay.
All right,
Okay. Thank you.
you're welcome. So we go back. We now obtain this 3. We now obtain this 1 using only the coordinates. Okay, using only the coordinates. Okay, so x value here and x value here, you subtract, you get the absolute value. The y value here and the y value here, you subtract, and then you get the absolute value. Okay? Going back to the triangle earlier, what was our formula? It should be 3 squared plus 1 squared, and then we get the square root. That's your distance d. So this squared plus this squared, you get the square root. That's equal to this guy here. Okay? So if we go further now, we will have the following. The distance of 1. So in here, I started with this point here. The 1 in the x-coordinate minus -2. So 1 minus -2, we get the square of that. Okay? And then 2 minus 1. That's your 2 minus 1. And then we get the square of that. You add them, you get the square root. And that will be the distance here. So if you calculated this, 1, so we got this 3 already. 1 minus -2, that's 3. And then you square it, that's 9. 2 minus 1, that's your 1. You square it, that's 1. And therefore, you will get the square root of 10. So again, that guy there is very much similar to your right triangle here. Okay, the right triangle. Uh, this has length 3, this has length 1. If this is your C, C is equal to the square root of 3 squared plus 1 squared. And that's your square root of 10. Okay? So this formula here, you don't need to draw this right triangle the way it was drawn or explained in here. Okay? You don't have to draw, sorry, in here. You don't have to draw this triangle and get the length of this base or the length of this altitude and then do your formula, Pythagorean formula. No, you don't have to do that. You just have to check the x coordinates and the y coordinates, okay, to get the distance. Okay? Let's look at another example. So we will not draw the triangles here anymore. Okay? You have the point 0, comma 1, and then you have the point 3, comma negative 3. Okay? So find the distance between the two. That's right here. Okay? You have, this is the x coordinate here, minus the x coordinate there. Okay? You square that, plus the x coordinate here, that's negative 3, minus the x coordinate here. Sorry, the y coordinate here, which is negative 3, minus the y coordinate there. So minus 1, and then you square that. You get the square root of this, and this is equal to the distance. Okay? So just the coordinates of the points. It's more than enough for us. Okay? So we have the calculation here. So 3 minus 0, so this is 3 minus 0 squared plus negative 3 minus 1 there, that's squared. And if we calculate, this is 3 minus 0, that's 3 squared, that's 9. Minus 3 minus 1, that's minus 4. If you square it, you have 16. And you will get square root of 25, which is equal to 5. Okay? Question? Next example here. Oh, I don't have my next example. Maybe later I will have more examples later. I will have, I want to introduce now a new formula here, the midpoint formula. Okay, so the midpoint, capital M, which we will label x comma y, of the line segment joining the points P1 and P2 is given by this formula. So, for example, as an illustration in here, say this is your P1, this is your P2, you get the line segment, okay? The midpoint is the one that is exactly at the middle, okay? It's exactly at the middle. So this is your capital M, okay? So the question is, how do we get that midpoint? Let us illustrate using this more general scenario here. This is your x1, comma y1. And then this is your x2, comma y2. And just like before, we draw triangle, okay? let's just draw this triangle here. And then, so we have this, particularly a right triangle, and we have this point here. So what is the coordinate of this? So in here, you are fixing y. So you have y1 in here. In here, on this vertical line, you are fixing x. So you have x2 in here. Okay? Now, let's look at a single line. You have your x1 in here, and you have your x2 in here. And there is the middle. You are given 2 points, x1 and x2. How do you get this middle? The middle is exactly the average between x1 and x2, correct? So if it is the average is calculated by adding the 2 and then dividing it by 2. So you have x1 plus x2 divided by 2. Okay? And similarly, if you have, say you're on the vertical, this is your y2, let's just say it's y2, this is your y1, okay? And then you look at the middle, and again, the middle is calculated using the formula for the average, y1 plus y2 divided by 2, which means you get the middle of x, the x parts. You also get the middle of the y part. Then you combine that. That's your midpoint for the 2 points P1 and P2. The middle for the x, it is x1 plus x2 comma 2, I over 2. This guy here. And then for the y, you have y1 plus y2 over 2. This guy here. So again, without drawing the actual triangle, all we need to use are the coordinates of the points. Okay? Okay? Question? So, let us try this example here. So earlier we have calculated the distance between these 2 points. Now we just want the midpoint. So the midpoint is somewhere here. Okay, so we use that formula. So for the x, you have 1 plus negative 2. Okay, 1 plus negative 2, and then you divide it by 2. For the y, you have your 2 plus 1, and then you divide it by 2. 2 plus 1 divided by 2. And whatever you get after your calculation here, you will have negative 1 half, comma, 3 halves. Okay? So that is the midpoint M. And if we check, it's in here. So this point here, it's negative 1 half. Okay, that's negative 0.5. And then positive 3 halves. That's your 1.5. Okay? So plain substitution of values in the formula. Okay. Another problem here. So this time, we want to find the midpoint of the line segment joining 4, -2 and the origin. Remember, origin it's 0, 0. Okay? The origin has coordinates 0, 0. So this is just 0, 0. Which means we calculate the midpoint. 4 plus 0 divided by 2. That's for your x. And then for your y, -2 plus 0 divided by 2. And if we simplify this, we'll just get 2, -1. And then here is our midpoint M. Okay? So now, now we will do more examples. So the rest of the presentations here are just examples. And we will do that. The solutions are not written in your notes. So we will do this all together. Okay? And we are just going to apply the formulas that we learned. There are only two formulas. You have the distance formula and you have the midpoint formula. Okay? So first example, starting the set. So find the distance between the given points, -5, 0 and -1, -3. So distance, plain formula, distance, this is equal to the square root. Let's write this longer. Square root of, so let's have the x, -5 minus -1. So -5 minus -1 squared plus, we have the y's, 0 minus -3 quantity squared. So this is the one we are using, distance. This is x1 minus x2 quantity squared plus you have y1 minus y2 quantity squared, and then you get the square root of that. Okay? So -5 minus -1, that's there. 0 minus -3, that's there. Then we just calculate. We have here -5 minus -1. It becomes -5 plus. Okay? It becomes -5 plus 1. So square root of -5 plus 1 squared. And then here you have 0 minus -3. It's just plus 3 squared. So I'm doing this completely. Then -5 plus 1, that's -4 squared plus 3 squared. And -4 squared, that's 16. Plus 3 squared, that's 9. And 16 plus 9, that's 25. And we get the square root of 25 now, which is equal to 5. So the distance between -5, 0 and -1, -3, it's equal to 5. Okay? If I ask you to graph these points first, okay, let's just draw any horizontal and vertical lines. So in here, this is your x-axis, this is your y-axis, and then you want -5 comma 0. So negative 5 on the x-axis. 1, 2, 3, 4, 5. So this is negative 5, negative 4, negative 3, negative 2, negative 1. And then your y coordinate, it's just 0. So you actually have this point. And then for the other points here, negative 1 comma negative 3. This is your negative 1 for the x-axis. For the y-axis, you have here negative 1, negative 2, negative 3. So negative 1, negative 2, negative 3. So negative 1 on the x-axis or on the x, and then negative 3 on the y. This is your point here. So again, this is the point negative 5 comma 0, and this is the point negative 1 comma negative 3. And you were asked to find the distance between these 2 points. So you were asked to find the distance between those 2 points. And according to this calculation, it's just 5. Okay? Next problem, find the distance between the given points. 2/3, comma, negative 3, and negative 1/2, comma, negative 5. So distance, this is equal to square root of quantity. You have 2/3 minus negative 1/2. So this x minus this x. Okay, and then you square it plus negative 3 minus negative 5 squared. And then you just do this. That's 2/3 plus 1/2. Okay, that's 2/3 plus 1/2. Let's say, so you have 2/3 plus 1/2 quantity squared there. And then in here, you just have minus 3 plus 5 quantity squared. And then you take the square root of this. And then this is equal to, so what is this? Let's see. LCD 6 for this guy, LCD 6. And then you have 4 plus 3, correct? Then you want to square this. And then for this guy, you just have minus 3 plus 5. That's minus 2. Then you square this. You get the square root of all these guys. So in here, you have 4 plus 3, that's 7. Then you square it, that's 49. And of course, the square of 6, it's just 36. Plus, so in here you have negative 2 squared, that's just 4. Then you combine this to a single rational expression and then simplify everything. Okay? So what is this? Let us continue with the simplification. So in here, common denominator or the LCD will be 36. In here, you have 49 plus. For the other guy here, 4 times 36. What is that? So 4 times 36, you have 4 carry 2, 12. So it's 144. Kindly check my arithmetic there.
Yeah, 144.
Thank you. And then we have 49 plus 1 for 4. That's 3. Carry 1, 8, 9, 193. And then you divide this by 36. You get the square root. So I'm not sure if 193 is a perfect square. Okay. But at least I know 36 is a perfect square. So maybe let's just write square root of 193 over 6. At least this is rationalized. So this is the distance between the 2 points.
If we need to simplify, for example, the 193, and on the exam, do we simplify? You know
Uh,
what I mean? Like putting, I don't know how.
Actually,
Yeah.
you don't have to.
Okay.
At least on the, oh, your next exam is actually a final exam already, correct? Um,
Yeah.
what will happen to that? Uh, yeah, if the number is large and you cannot get the radical or the root of that easily, you can just retain that. But for those numbers which we should know at least by heart, for example, 36, we know it's 6 squared. So try to simplify those.
Okay. Thank
Okay,
you.
you're welcome. Next problem. Find the distance between the points a comma negative b and minus a comma b. So we have here arbitrary numbers. So we just write this. Distance is equal to the square root of, here you have a minus negative a quantity squared plus, you have now minus b coming from this, then minus b quantity squared. So in here, what do we get? You have square root of 2a quantity squared plus, here you will have negative 2b quantity squared, and you take the square root of this. So if we simplify this, we'll just have 4a squared plus 4b squared. You take the square root. You can factor out 4. So you will have 4 times a squared plus b squared, and again take the square root. And then you have square root of 4. That's just 2. So this is just 2 square root of a squared plus b squared. So this is the distance between those 2 points. Okay. Next problem here. Find the distance between the given points, square root of 2 comma 2, and the origin. So again, the origin, it has coordinates 0 comma 0. So if you use the distance formula, this is just square root of, for emphasis, we write square root of 2 minus 0 squared plus 2 minus 0 squared. Again, for emphasis that you are getting the distance between this point and this point. That's why we put this minus 0 and minus 0 in here. And then you can just square that square root of 2. So you'll just get 2 there. Then plus. Here you have 2 squared. That's 4. Okay. And therefore, this is simply square root of 6. And that's the distance between those 2 points. Question. Now, we want to find the midpoint. Okay, midpoint of the line segment between the given points. So we have this 4, 3 and negative 2, 5. So remember the formula? I'll just write it here again. Midpoint, the formula that you need to remember, it's x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma, parentheses. So this is the midpoint. Therefore, m in here, using the formula, it's just 4 plus negative 2 divided by 2. So you have your 4 plus negative 2 divided by 2, comma, here you have 3 plus 5 in here divided by 2. So in here you have 4 minus 2, okay? 4 minus 2, so it's 2 over 2, comma, in here you have 3 plus 5, that's 8 over 2, and therefore this is just 1, comma 4. So this is the midpoint. Okay? Next. Midpoint between negative square root of 2, comma negative 5 and 3 square root of 2, comma 3. So for this, you have m equals. You have, for the x part, we have negative square root of 2 plus, then we have 3 square root of 2 divided by 2, comma, here you have, for the y, you have minus 5 plus 3 divided by 2, then close parenthesis. Simplifying, so minus the square root of 2 plus 3 square root of 2, that's 2 square root of 2. And then you divide by 2, comma. Here you have minus 5 plus 3, that's minus 2 divided by 2. And therefore, we have square root of 2, comma, negative 1. So this is the midpoint. Okay? Question. Now, let us do some more not so easy problem. Find the endpoint of the line segment whose midpoint is negative 1, comma 3, and the other endpoint of the line segment is negative 5, comma 4. Okay? So how do we do this? We start with, say, let x, comma y be the other point, be the other endpoint. other endpoint. Okay? Then x plus, this is the other endpoint of the line segment. So x plus negative 5 over 2, comma, y plus 4 over 2. This is the formula for the midpoint. The x coordinates, you add them and then divide by 2. The y coordinates, you add them and then divided by 2. So x plus negative 5 over 2. And then y plus 4 over 2. So this is the midpoint. But we know that the midpoint is negative 1, comma 3. Negative 1, comma 3. So meaning, this x coordinate must be equal to negative 1. And this y coordinate must be equal to positive 3. Okay? So, you have x. This is x plus negative 5. So, I'll just write x minus 5 divided by 2. This must be equal to negative 1. And y plus 4 divided by 2. This must be equal to 3. Okay? And then you compute for what? For the value of x and for the value of y. So if we calculate this, for the x, let's compute the values of x, the value of x. You have x minus 5. So you cross multiply. So you multiply 2 on both sides of the equation. That will give you x minus 5 equals negative 2. Or you have your x equals negative 2. You put this minus 5 from the left-hand side to the right-hand side, it becomes plus 5. And minus 2 plus 5, this is equal to 3. So the x here must be equal to 3. And then for the y, same. You multiply both sides of the equation by 2. You will get y plus 4 equals 6. And then this will give us y equals 6 minus 4. And 6 minus 4, that's equal to 2. Okay, therefore, the other endpoint is, okay, the other endpoint is 3, comma 2. Okay? Question? Let us proceed with our next problem. If one endpoint of a line segment is 2/3, comma 5/2, and the midpoint of the segment is negative 3, comma 1/2, find the other endpoint of the line segment. So similar question as in before. You start with naming the other endpoint. So let x comma y be the other endpoint, Then you have the midpoint, which is this. And the midpoint can be calculated by using our formula. So then you have your x plus 2/3 divided by 2, comma, y plus 5/2 divided by 2. This must be equal to -3, 1/2. So same solution as in before. And therefore, again, x coordinates must be equal, y coordinates must be equal. So let's just write that. X plus 2/3 over 2 must be equal to -3. And for the y, you have y plus 5/2 over 2. This must be equal to 1/2. So we calculate for x. We multiply both sides of the equation by 2. We have x plus 2 over 3. Okay. This must be equal to -6. Or we have x equals -6 minus 2/3. So if you simplify this, you should get -20 over 3. Okay? And then for the y, you have y plus 5/2. You multiply both sides of the equation again by 2. So this must be equal to 1. Then you solve for y. You have y equals 1 minus 5/2. Calculate this. You should get -3/2. So conclusion, the other endpoint is -3/2. -20 over 3, -3/2. Okay? Question. Next problem. Find the perimeter of the triangle whose vertices are -2, 1, 4, 3, and 1, -3. Okay? So you just want the perimeter of the triangle. So it means you get the distance pairwise, and then you add those distances. But let us try to visualize this. Let us draw the Cartesian plane. Okay? And then on this Cartesian plane, so again, this is your x, this is your y. You have your 1, 2, 3, 4. So I'm gonna plot this 4, 3 first. So 1, 2, 3, 4 for the x, and then for the y, you have 1, 2, 3. So 1, 2, 3. So 4, 3, it's somewhere here. Okay? So this is your 4 and this is your 3. So this is your 4, comma 3. Then the other vertex, it's negative 2, comma 1. So let us have this negative 1, negative 2. So negative 2, comma 1, this is negative 2. And then this is your positive 1 for the y. So the point may be somewhere here. So this is negative 2, comma 1. And then the other vertex, you have 1, comma negative 3. So we already have 1 for the x. Let's just write negative 3 for the y. So 1, 2, and 3. So this is negative 1, negative 2, negative 3, and therefore you have this point. So this is the point 1, comma negative 3. Okay? And we have the triangle here. This guy here, this guy here, and then. So this is the triangle. And we need to find the perimeter. So get this distance plus this distance plus this distance. So you just have to use distance formula 3 times. Okay? So let's do that. So for emphasis on which points we are using to find the distance, I'll put the points also inside the parentheses here. So I'm gonna get the distance between 4, 3, and 1, negative 3. So 4, comma 3, comma negative 1, comma 1, comma negative 3. Okay, so we focus on these points first. This is square root of the quantity 4 minus 1 squared plus 3 minus negative 3 squared. So if we simplify this, we will have the square root of 4 minus 1, that's 3 squared, plus 3 minus negative 3, that's 6. So 6 squared. So 3 squared, that's 9. 6 squared, that's 36. So in here we have square root of 9 plus 36, that's 45. Okay. And this guy here, try to check that this 45, it's 9 times 5. And we take the square root. So this is 3 square root of 5. Okay, so try to check that one.
Why you didn't do the -2 and 1? We're gonna do
Not
that
yet.
after?
Yes, we're gonna do that.
Okay.
Look at
Okay.
this. We are just in the distance between 4, comma 3 and 1, comma negative 3. Now let's consider the distance between these 2 points. Okay. So distance now between 1, comma negative 3, comma negative 2, comma 1. So this is square root of, we have 1 minus negative 2 quantity squared plus minus 3 minus 1 quantity squared. And what do we get? 1 minus negative 2, that's 3. So you will have 3 squared plus negative 3 minus 1, that's negative 4. So negative 4 squared, and you will get here square root of 9 plus 16. And again, this is square root of 25, which is equal to 5. And then finally, we get the distance between these 2 points. Okay? So distance now between negative 2, 1, comma 4, 3. Okay? So this is square root. Square root of negative 2 minus 4 quantity squared plus 1 minus 3 quantity squared. Okay? Then minus 2 minus 4, that's minus 6. So minus 6 squared plus 1 minus 3, that's minus 2 quantity squared. So we'll get 36 plus 4 in here. And this is square root of 40. Square root of 40, simplify it as 2 square root of 10. And therefore, the perimeter is just the sum of these three guys. Okay? So, perimeter is what are those? 5 plus 3 square root of 5 plus 2 square root of 10. Okay? So ugly values, but that's how you have to do it. Okay? So this distance plus this distance, and then plus this distance. Okay? Question? Next problem. Find the area of the rectangle whose vertices are 3, 5, negative 2, 5, negative 4, negative 2, negative 4, and 3, negative 4. So again, let's try to visualize this. You have the Cartesian plane. We need 3, 5. So 1, 2, 3 for the x. And then you have 1, 2, 3, 4, 5 for the y. So 3, 5, it's somewhere here. So it's somewhere here. Let's see. 3, 5. And then we need negative 2, 5. So we have here negative 1, negative 2. So again, let me just label this. And then this guy here. And then this guy here, it's negative 2. So the point negative 2, 5, it's roughly here. So negative 2, 5. And then you have negative 2, negative 4. So now we go down y-axis. Negative 1, negative 2, negative 3, negative 4. So this is our negative 4 here. The point is roughly here. So we have negative 2, negative 4. And then finally, you have 3, negative 4. So you have the positive 3 for the x, negative 4 for the y. So the point, it's roughly here. So this is your 3 comma negative 4. And therefore the rectangle, it's just this guy here. So assume that it's a rectangle. Okay? But that's the rectangle that we desire. So we want to find the area of the rectangle. And we are assuming that this is a rectangle. So this could be your width or length. This could be your width. So all you need to do is to find the distance between these 2 points here and then maybe these 2 points. Meaning you don't have to use the fourth point. Okay? You don't have to use the fourth point. So let's look at the distance between these 2 points. Okay? And you will see that it's easy. Okay? So you want the distance between 3, comma 5 and 3, comma negative 4. So this point here and this point here. So notice you have the same x coordinate. Okay? You have the same x coordinate. It means the distance between the x coordinates is just 0. Indeed, you will just have 3 minus 3 there. Okay? So 3 minus 3 squared. And then for the other guy, you will have 5 minus negative 4. And then you square that. So in here, what you will get, again, 3 minus 3 is just 0, so let's throw it out. Here you have 5 minus negative 4, that's 9. Then you square it. And then don't square it because you have a square and then the square root. That's just equal to 9. It's like the square root and the square will cancel each other's operations. So meaning the distance from this up to this, it's 9. Meaning the length of the rectangle, it's 9. Let's look for the width of the rectangle. So this time, we want to find the distance. Let's use this point and this point. Okay, this point and this point. So you have 3, comma 5, comma negative 2, comma 5. And now, here you see that you have the same y coordinates. And you will see that you just need the x coordinates respectively. So here we will have square root of negative 2 minus 3 squared plus you have your 5 minus 5 squared. So in here you have square root, and again you have 5 minus 5 here. Let's just throw it out. You have 0 there. And therefore you'll just get negative 5 quantity squared. And then you have square root and squared. They will cancel each other, but take note, this should be absolute value of negative 5. And therefore you have 5. Okay? So the width of this rectangle is 5. Therefore, area is equal to length times width. So 9 times 5, this is equal to 45 square units. Okay? Square units. And by the way, in the previous, here let's just formalize since we are looking at the perimeter. So let's just say this sum units. Okay? And here, since we are talking about area, it should be square units. question. Next problem here. Find the point of the y-axis. It should be on. Find the point on the y-axis. Okay. So find the point on the y-axis whose distance to the point 3, 5 is 5 units. Okay. Let's visualize this. So here you have this is your x and this is your y. Okay, and then you have 3, 5. So 1, 2, 3, and then 1, 2, 3, 4, 5. Let me adjust the y there. 5. So this is your 3, 5. So this is the point 3, 5. And then you want to find a point on the y-axis whose distance from this point, okay, to that point on the y-axis is 5 units. Okay? For example, we don't know. We don't know where the points or point is. But I will tell you there will be 2 points here. Okay? There will be 2 points here. One of the points is possibly here. Okay? And I don't know if it is on the tick here or on the tick here or somewhere on some other ticks, but definitely it's on the y-axis. That's what we wanted. Find the point on the y-axis. What we're sure of is that since this point is on the y-axis, its coordinate is of the form 0, y. The x-coordinate is equal to 0. Correct? Because we want the point to be on the y-axis. So the x-coordinate must be equal to 0. So we want to find the distance between 3, 5 and this point here. It could be somewhere here. Actually, we will show that there are 2 points possible. Point is somewhere here. The other point is somewhere here. Okay? But what we're sure is if we find the distance from 3, 5 to the point 0, y, it should be equal to 5 units. Okay? So let's start with our algebra here. Let 0, y be the desired point. Desired point. And I am telling you that it will be 2 points. So I am putting the S here. Then we want D equals square root of 3 minus 0 squared, okay, plus 5 minus y squared. So that's the distance between this point and this point here, or the other point somewhere here. but we want the distance to be equal to 5. This must be equal to 5. So now we are left to solve for y. But this is easy. We'll just what? Do the computation. So for this part here, this is just 3 minus 0 squared. So you will have 9 squared, oh sorry, it's 9 plus, in here, I suggest you don't expand. Okay, I'm gonna show the solution why. You don't need to expand. So I'll just write quantity 5 minus y quantity squared. So you have the square root. This is equal to 5. And the next, you square both sides of the equation. You square both sides of the equation. You will get 9 plus 5 minus y squared. This is equal to 5 squared, and this is equal to 25. You square this guy here, you square this guy. But the square of 5, it's 25. And then we solve for y. We move the 9 to the other side. So you will have 5 minus y squared. This is equal to 25 minus 9. But 25 minus 9, that's just 16. Okay? And now, 5 minus y squared equals 16. You can now get the square root of both sides of the equation. But take note, you are taking the square root. Don't forget to put the plus and minus. So you will get 5 minus y equals plus or minus square root of 16. But square root of 16, that's 4. Still following?
Yes.
Thank you. And therefore, we can solve for y because this is just linear. We can move the y to this side and then this plus or minus 4 to this side. But take note, if you move this plus or minus 4 on this side, you flip this, it becomes minus plus. But anyway, it doesn't have an effect. You put plus or minus plus, it's totally fine. At least for this. Okay, at least for this equation. But I'll do it more formally in that sense. So I will move plus or minus 4 from this side to this side. It becomes y minus plus 4. This is equal to, and then I move this minus y from the left going to the right. It becomes just y. So in the end, you will have your y equals 5 minus 4 is equal to 1, or y equals 5 plus 4, which is equal to 9. Okay? Therefore, the points are, the desired points are, so the desired points are, we have 0, 1, and you have 0, 9. So this point here should be on this part. Okay? So let us move that point. So in here, so we want to remove that. So the point that we actually need is somewhere here. And then the other point that we can get, it's somewhere above here. Okay? So this means this distance here, okay? This distance here, it's equal to 5. Also, this distance to that point somewhere there, okay, it's also equal to 5. Okay? Question before I proceed to our last example. Okay. Our last example here, find x. If the distance between x comma negative 1 and 2 comma 1 is equal to 2 square root of 2. So direct substitution of the distance formula. Okay. So we need, which is the d, we need the distance square root of x minus 2 quantity squared plus negative 1 minus 1 quantity squared. This must be equal to 2 square root of 2. And then the same formula as in the previous example. Or I mean the same computation as in the previous example. Okay? So on this side, we retain x minus 2. Again, do not expand. There is no need to expand that. And then in here, you have minus 1 quantity squared. So let's just write it minus 2 quantity squared. You get the square root of this, and you have 2 square root of 2. Then we square both sides, and at the same time, we square this negative 2. And we will get x minus 2 squared plus negative 2 squared, that's 4, equals 2 square root of 2 quantity squared. This is equal to 8. Okay? Then we solve for x. So we isolate this part here. We have x minus 2 quantity squared. This is equal to 8 minus 4. So we move this 4 here to the other side. Okay? So we get this x 8 minus 4. And that's equal to 4. Okay? Then now we take the square root. And again, taking the square root, don't forget that plus or minus. So plus or minus square root of 4, and that's just 2. So plus and minus 2. And solving for x, you have here x equals plus and minus 2 plus 2. The plus 2 came from this guy here. You move it to the other side. Which means two possible values for x again. X equals plus 2 plus 2, that's equal to 4. Or the other guy, you have x equals minus 2 plus 2, that's equal to 0. So these are the values for x. So the point 4 comma negative 1, okay, if you get the distance of 4 comma negative 1 from 2 comma 1, you'll get 2 square root of 2. Similarly, if you get the distance from 0 comma negative 1 from 2 comma 1, you'll still get 2 square root of 2. Okay? So as I've said, that's my last example. I want you to work on as many problems as you can on pages 84 to 85 of 016 module. And the previous examples that I gave, that set where we did the examples all together, it came from the module. So you will find those problems on the module or in the module. Okay. So that's all for me for today. Thank you for staying.